All right, so next we want to go ahead and these look like types of quadratics, especially if we rearrange them, but they're not quite quadratic. They have a higher degree than 2. But we can use our knowledge of quadratics to solve them. So if I rearrange this such that it's equal to 0, I could have 5x squared plus 8x cubed minus 4 equals 0. And the trick here is you let u equal this middle thing. So u equals your x to the third. Sorry, not the whole middle term, but just the variable. If you think about u squared then, x to the third squared gives us x to the sixth. So in essence, I can rewrite this equation 5u squared plus 8u minus 4 equals 0. Now we've got a factoring equation. So you're saying what multiplies 5 times negative 4 is negative 20. What adds to 8, you'd have 10 and negative 2. Remember here, you cannot just write x plus 10, x minus 2 because there's a coefficient up front. So I usually break apart this middle term into 10u minus 2u coming from these two factors equals 0. And then look for the GCF. There are other ways to divide by the 5u. I'm fine with that as long as you know how to do it, go for it. So 5u and negative 2 are your two greatest common factors. As you divide those terms, you get u plus 2. As you divide these terms by negative 2, you also get u plus 2. So 5u minus 2 and u plus 2 equals 0 is the factored form. If I solve that, this one you probably know is u equals negative 2. This one, if you need some help, remember setting it equal to 0. Think about solving for u. So you add 2 to both sides, then you divide by 5 and you get 2/5. Remember though, at this stage, you've got to plug back in x cubed. So to undo a cubed, you're doing the cube root of both sides. So x equals the cube root of 2/5. Same thing here. Plug it back in, you get the cube root of negative 2, x equals. And that would be your two solutions. Since it's the cube root, we don't mind that there's a negative in there, but be careful. If it was a square root, we want to discount the imaginary numbers. This one is really, really similar. Set it equal to 0, and this time you let u equal x to the 1/4. So then u squared is x to the 1/2, because as you do 1/4 times 2, you end up with a half. I'll let you go ahead and take a moment to solve that. All right, so here are your two final answers. You've got x equals 3 to the 4th, or x equals negative 2 to the 4th. You could rewrite that as 81 and as 16, but either way you write it, you have the same answers. Make sure that if you do negative 2, it's in parentheses. Okay, last but not least, we're going to do example 7. So it says Sue wants to put a rectangular garden on her property using 88 meters of fencing. There's a river that runs through her property, so she decides to increase the size of her garden by using the river as one side of a rectangle. Fencing is then needed on the other 3 sides. Let x represent the length of the rectangular perpendicular to the river. So if that's x, it means this side's also x. Express the garden's area as a function of x, and then find the maximum area of the enclosure. So I'm going to call this other side y. So the area then would equal x times y. But notice that's not a function of x. So let's talk about the relationship here. We know these 3 sides has a total of 88 meters. So if you wanted to add your 2 x's, you got 2x plus y equals 88. So then, if we solve for y equals 88 minus 2x. I'm now going to plug that in for y. So x equals 88 minus 2x. If I multiply that through, I get 88x minus 2x squared. That's the function of the area in terms of x. But now let's actually talk about that because it's asking us for a maximum. Notice if I rearrange this, you may start to recognize this quadratic a little bit more. Specifically, this quadratic opens downward. So if we want the maximum, what point are we talking about on the quadratic? We're talking about the vertex. So how do you find the vertex of something in this form? Think back to your quadratic formula. We're talking about negative b over 2a is the x value of that vertex. So negative x equals negative b over 2a. In this case, b is 88, so negative 88 over 2 times the negative 2 is negative 88 divided by negative 4, so we get 22. Up to you at this stage. At this stage, you can either plug 22 back in this equation to find the area, or I could just figure out what the other side is, which in this case, since I don't have my calculator right here, is probably a little easier. Y equals 88 minus 2 times 22, so we get 44. So the two lengths are 22 by 44 meters, so if I want the area, I'm going to multiply those two together. If I remember correctly, it's 986 meters squared. And that would be your maximum area. Fun fact for you, notice that this is just half of what the length you have for it is. All right, that's it for the quick brief notes. Remember, I do have all the notes on campus though, if you want to look under modules in that top section. But feel free to come in and ask questions. Good luck on your homework.